Hi guys, welcome to your algebra class. Today we're going to be solving quadratic equations by completing the square. So before I give the answers on the first 10 perfect squares, if you want to pause the video now so that you can fill them in yourselves, you can go ahead and do so. So I'm hoping by now that you have these perfect squares memorized so that when you see them, you instantly recognize that they're perfect squares. So the inverse operation of squaring, meaning the opposite operation, is to square root. So the example that I give is that since 3 squared is 9, and negative 3 squared is also 9, then when you do the opposite and you take the square root of 9, you're going to get either the positive version of 3 or the negative version of 3. So when you write your answer, you're going to put the plus or minus symbol before the number. So when we start filling in the square roots of these perfect squares, all of our answers are going to have this plus or minus symbol, and then when we take the square root of 1, our answer will be 1. So again, you can pause the video now and fill in the rest of the answers before I do, and then we'll go through them. Okay, so there's your answers. Obviously, you should see a pattern, but in all things in math, if you look deep enough, you'll find a pattern. So hopefully this makes sense, and we're going to move on to the steps to find the roots, which again, roots, remember, are where it crosses the x-axis. So we're going to find the roots, but instead of factoring like we did last week, we're going to use the process of completing the square. So the first step is that we're going to isolate the x terms, meaning keep anything that has an x on one side of the equation, and in the same process, we're also going to find what I call the b's. That would be b over 2, and b over 2 squared. So b, again, is the term that is in front of x. So whatever that number is in front of x, that's what we focus on. So we figure out what is that number, we take that number and we divide it by 2, and then we take that answer of b over 2 and we square it. And that squaring term is partly why we call this process completing the square. So on to step 2, and this will make more sense when we actually do a problem. But step 2 is that we're going to take that b over 2 squared term and we're going to add it to both sides of our equation. And the reason that we want to add it to both sides of the equation is because if we only add that number to one side, then the equation is no longer balanced and we've messed up the whole process. So we always add it to both sides. Okay, so step 3. Step 3 is why we had to learn how to factor before we could complete the square. So step 3 is where we actually factor and we rewrite this process as one set of parentheses squared. And you'll get the hang of this over time where it just comes really natural to you, but again, it's going to take some practice. Now, this might look like gibberish at first, but the reason that in step 1 we found not only b, but b over 2 and b over 2 squared is because we had to use the b over 2 squared term to add to both sides, and then we used the b over 2 term to factor. And this is just always going to be a pattern that works where you'll have your b over 2 term in the parenthesis, and because it is the same concept written twice, like this x plus b over 2 times x plus b over 2, you can shorten it and write it as one set of parentheses, x plus b over 2, the whole thing squared. Now on to step 4. Step 4 is where we take the square root of both sides of the equation. And obviously we have to take the square root of both sides of the equation, again, to keep that balance intact. And then the final step is just simply solve. So solve for x. And remember, what this x represents is it represents the roots of these quadratic equations. So if you think back to when you were graphing parabolas and you had a U-shaped parabola, wherever it crosses the x-axis, those would be your roots, and that's what we're finding again in these scenarios. So most of the time we'll have two answers, two roots. Okay, so pause here if you need to write anything down of these steps before we move on to the next examples. So in example 1, if we look at our steps, we have to isolate the x terms first. So our x terms are the x squared and the negative 14x. And the 3 is currently on the same side as those x's, so we need to move the 3 to the opposite side, and in order to do that we need to use the inverse operation, and so we need to subtract 3 from both sides. So when we do that, we're still left with x squared minus 14x. We're going to leave a little bit of a space because we're going to add something in that space in the second step. And then on the other side of the equation, we'll have negative 13. Now we have to, in the step 1 still, we have to find what I again call the b's. So we need to find what is b over 2, and what is b over 2 squared. So we always start with b. B again is the number that is in front of the x term. So in this scenario, b is negative 14. And the negative does matter, so make sure that you include it. Now b over 2 would be negative 14 divided by 2, which would turn into negative 7. And b over 2 squared would be negative 7 squared, which would turn into a positive 49. And remember that we call this completing the square for a reason. So we are going to use that squared term, that 49, and we are going to add that 49 to both sides of the equation. Okay, so step 1 and step 2 are done. Now for the factoring. So if you focus on this trinomial, right, what you have on the left, in order to factor this, you have to remember what multiplies to positive 49, but also adds to negative 14. And you would start by breaking up x squared by x and x, and then you would figure out that, well, negative 7 and negative 7 would multiply to positive 49 and add to negative 14. Now, it's not a coincidence that negative 7 is also my b over 2 value. This will always happen. So I'm going to star this step because technically you can skip it in the future if you know the pattern, right? And then I almost forgot to add negative 13 and 49 together to get 36. So if we skip this step, because we know the pattern will always be x plus my b over 2 term. Now because my b over 2 term is negative, it's going to be minus 7 squared. And the reason that it's squared is because if I look above, this x minus 7 times x minus 7 is the same thing as x minus 7 squared. So again, that equals 36. Now I can look to step 4. Now, step 4 says to take the square root of both sides. So I can do that now. 36, I should recognize, is a perfect square. But before I just write an answer of 6 below, the square root of 36 is actually plus or minus 6. And that's important. That is the reason, that plus or minus is the reason why we're going to end up with 2 answers. Now when I take the square root of x minus 7 squared, the square root and the square are going to cancel each other out because they are inverse operations of each other. So all that I'm left with is the x minus 7. Now I have a one-step problem that I can solve to get x alone. So if I add 7 to both sides, here's how I'm going to end up with two answers. One answer will be the positive 6 adding 7, which would give me 13. And the other answer would be negative 6 adding to 7, and that would give me a positive 1. So my two answers are 13 and 1. And again, we just found the roots for where this quadratic crosses the x-axis. Okay, the last example for the notes. So if we look at our steps again, we have to isolate our x's, and that means that we need to add this 7, which is not attached to an x, to the other side of the equation. And when we do that, we want to leave a little bit of a space so that we can add something in. In the same step, in the same process, we're also going to be able to find our b's. So we need to figure out what is b over 2, and what is b over 2 squared. So when you start with finding what's b, you always look at the number that is in front of x, so b would be 6. When you take 6 and you divide it by 2 to find b over 2, you're going to get 3. And when you take your b over 2, your 3, and you square it, you're going to get 9. Again, we call this completing the square for a reason. We're going to take that squared term 9, and we're going to add it to both sides of our equation. Now, in this process, I'm going to skip that step that I said we could in the last equation, and I'm going to use this pattern process where I always use the b over 2 term in my parentheses. So this is going to turn into x plus 3, the whole thing squared. And if you don't believe me, the reason it is because 3 times 3 is 9, and 3 plus 3 is 6, so that's going to work out well. And on the other side of the equation, 7 and 9 added together is 16. So, step 4 of my process would be to take the square root of both sides. And when I take the square root of both sides, I'm left with x plus 3. Remember, the square root of 16 is not just 4, it is plus or minus 4. And then the final process of solving for x is to subtract 3. So when I subtract 3, one answer would be using the positive version of 4 and subtracting 3, which would give me an answer of 1. And the other version would be using the negative 4 and subtracting 3, and that would give me an answer of negative 7. So those are my two roots where my parabola would cross the x-axis. And that is it for the notes. Hope you enjoyed.